Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 6 of the AKD Ethernet IP video series. This video will cover best practices, add-on instruction timing, and common mistakes in implementation. The AKD Ethernet IP drive is set up as a generic Ethernet module in the PLC. When setting the RPI on the connection tab, the requested packet interval, be aware of setting it too low or fast. It is important to note on the connection tab in the sample project that the RPI is set to 40 milliseconds. And the Use Unicast Connection over Ethernet IP checkbox is checked. This is based on that during commissioning that typically you will have Workbench software and the PLC polling the drive, and Workbench and the PLC both use the service port on the AKD. The Use Unicast Connection over Ethernet IP will help suppress broadcast and help with network traffic. The general rule, again, is based on experience. Do not set the RPI lower than 40 milliseconds when using both Workbench and RS Logic simultaneously. Do not set the RPI lower than 20 milliseconds when using RS Logic alone. Do check the Use Unicast Connection over the Ethernet IP connection checkbox. Attempts to set the RPI lower than 20 milliseconds will result in missed packets, timeouts, and overall communication issues. Another very important rule to understand is that only one add-on instruction can execute at a time per axis. This is because the add-on instructions use bytes 0 to 32 as shown below of the command and the response assemblies, which are tied to a specific drive and IP address. To trigger another add-on instruction while another is executing would overwrite this data. This will be covered in more detail shortly. In regards to triggering and implementing the add-on instructions, there are three basic cases or implementations of the add-on instructions. An add-on instruction that's tied unconditionally to the left rail, an add-on instruction that does not include a process complete bit, an add-on instruction that includes a PC or process complete bit. So again, just to emphasize, the AKD drive add-on instruction example of an add-on instruction is tied unconditionally to the left rail as required to be evaluated and executed on every scan. Case 2, an add-on instruction that does not have a process complete bit on the output. The AKD enable is an example of an add-on instruction that has only two output status bits, done or error. In the rung above, the enable contact triggers a one-shot to enable the add-on instruction. The enable end is sealed in until 1, the done or success is made, or 2, error, failure. Case 3, we show that AKD home. It's an example of where the add-on instruction has, in addition to the done and error output status bits, it also has in process and process complete bit. The start move home contact triggers a one shot to enable the add-on instruction. The enable end is sealed in until either 1, process complete or success, or failure, error. It's important which method to use is dependent on what add-on instruction is being used in the latter. For example, the AKD drive add-on instruction requires that it scan unconditionally. but this will cause problems if you implement other add-on instructions like the AKD home or AKD move add-on instructions in that same way. Pay close attention to best practices. Triggering the add-on instruction. The common mistakes with the AKD enable block as an example. Example 1, this rung only enables the add-on instruction for one scan, which is not long enough to execute or finish executing. You'll notice in that logic there's a toggle bit to command the enable drive, and there was a one shot, but this only one shots it for one scan. The next example gets rid of the one shot and there's only a toggle bit. In this case, if it was the enable drive contact was toggled to turn on, this rung would potentially keep the add-on instruction enabled forever if the contact stays on or is forced on, conflicting with other add-on instructions that you may try to trigger or execute. In this example, it's always on, unconditionally enabled forever, and then this would also cause conflicts if you tried to trigger another add-on instruction. It is best practice to have the AKD drive add-on instruction at the top of the routine or subroutine. It needs to be evaluated first in the scan, and the add-on instructions for that axis that are codependent on the AKD drive add-on instruction should be evaluated later in the scan. You'll notice in our sample project we put it at rung 0. Another note, the AKD drive communication add-on instruction functionality is tied to the generic Ethernet module and thus IP addresses as well. The handshake with the cyclic data of the command and response assemblies are tied to the axis input and axis output of this block when declared. The axis internal is the name you want to give to the axis throughout your program, for example, vertical lift or conveyor, etc. All other add-on instructions depend on this handshake and the axis name defined by the axis internal. Once declared at the top of your program or subroutine, all the add-on instructions used in the ladder code that follows related to that axis must have the same name in those add-on instructions as well when configuring the add-on instruction and inputting the axis name into axis for the AOI. For multiple axes, this must be true for every axis. This is how the add-on instructions know which axis it is related to. The done bit on the add-on instruction output status. Do not always assume that the done bit is indicating the add-on instructions process is complete. The done bit in many cases means the add-on instruction was successfully triggered to execute, but not necessarily that the add-on instruction is finished processing the command. Use the process complete PC bit when possible, or use diagnostics and status words to confirm completion or change of state. Often programs will use the done bit to move on to the next step, which can cause lockups or other issues. The reason for this, again, is the done indicates the add-on instruction has been successfully enabled to execute, not necessarily that it is completed execution. In some cases, the done bit may indicate the add-on instruction execution is complete done. But in other cases, like add-on instructions with the PC process complete bit, provide an indication that the add-on instruction execution has actually completed. There are also status words and information in the response assembly that can be used to confirm completion states, etc. More on this topic later. The process complete add-on instruction output status bit. Often programmers will use the process complete PC output status bit of an AKD move add-on instruction, for example, to trigger the next move add-on instruction. An example would be the AKD move instance name extend, and another AKD move instance name retract. During cycling, the first move would be commanded, and then on process complete, PC bit would be used to trigger the next move, retract. It is highly important to note the PC bit of the AKD move add-on instruction is dependent on two conditions. One, the trajectory is complete, and two, the end position on target bit in the status word over Ethernet IP is true. The end position window is set in the AKD by the parameter keyword mt.tposwnd, which is set by default to 0.5 revs of the motor or equivalent distance in the set position units. For example, in our sample project, we set all the units to custom, and we define that there are 65 536 counts per 1 rev, which is consistent with Ethernet IP units. And then in this case, the mt.tposwnd, when queried in terminal, would indicate 32 768 counts per rev. Please see the Workbench help for more details on this parameter. An application note is available on this topic by request. Add-on instruction instance names. Do not name add-on instruction instances with the same name or same tag name. An instruction added to your project must have a unique instance name. We've seen some cases where the program had two add-on instructions with the same name, and this can cause undesirable behavior. Here's an example of two AKD move add-on instructions with each having a unique instance name. You'll notice in the first rung that it's called axis underscore 1 underscore move, and then the next one is called axis underscore 1 underscore move 2. You can name this anything you want, but each instance should have a unique instance name.